studying the relationships of the lengths of sides and the measurements of angles. Here it is, key phrase, between two triangles. Okay? Now remember, in a previous video, let me get something marked here. Hold on one second, guys. In a previous video, we studied the relationship between sides and angles within one triangle. Remember, we said that the biggest angles across from the biggest side and the biggest sides across from the biggest angle, etc. Now we're going to look at some theorems too, to be precise, dealing with two triangles. Okay, so it'll be a little different. All right, here we go. Your heading today is relationships of angles and sides between triangles. Okay, it's a long heading, so please copy that down. Relationships of angles and sides between triangles. Lesson 5.4, and be sure and include today's date. Okay, lesson 5.4, and be sure and include today's date. Lesson 5.4, and be sure and include today's date. And here we go. Now, as I mentioned earlier, we're going to be studying two theorems. So let's jump right into this, okay? Here we go. Copy this down, please. You're responsible for this theorem, so please copy this down. Theorem 510, the Hinge theorem. Okay? Theorem 510, the Hinge theorem. Go ahead and copy this down. If two sides of one triangle are congruent to two sides of another, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. Okay, it sounds really difficult to understand, but it's really not that bad, okay? So copy that down, and then we will take a look at it. Okay, I'm going to go ahead and slowly start drawing two triangles. So if you're still copying this down, take your time. That's fine. Now, watch what I'm going to do. I'm going to draw a triangle like this, students. Okay, like this. I'm going to draw two triangles. Okay, one like that. And then what I'm going to do is not that. Then I'm going to do this. And then make this angle up top here a little bigger. Try to anyways, hopefully. There we go. Now I know my two drawings aren't perfect, but we're going to pretend they are, okay? Okay, here's what this theorem is saying, guys. We're going to call this first triangle, triangle ABC, and the second triangle DEF, okay? Now watch carefully. Are you ready? Look, if two sides are congruent to two sides. So put a mark here, even though they're not congruent, we're going to pretend they are. Two marks here, and two marks here. Okay, so if AB is congruent to DE and BC is congruent to EF. Now what else, guys? Here we go. You ready? What else? The included angle of the first. Now here's your two sides. So what would the included angle be? B. Here's your two sides. What would the included angle be? E. Okay? So the included angle of the first is larger than the included angle of the second. So we're going to call this, I don't know, 95 degrees. And we'll call this 100 degrees. Okay? Just making up some numbers. So then comma, angle B is greater than, did I say that wrong, guys? Sorry about that. Let's back that up, okay? Sorry, your old teacher's getting old here. Make this 100 degrees. And make this 95 degrees, okay? There we go. So now we're going to say angle B is greater than angle E. Okay, that's all of your if part. Look, if two sides of one triangle are congruent to two sides of another, and the included angle of the first is larger than the included angle of the second. So there's all of our if part. Then, here we go, what we've been waiting for with excitement. Here we go. Then, the third side of the first, right here, is longer than the third side of the second. Okay? So there we go. Now I know my triangles aren't drawn to scale, and if you want to draw yours better in your notes, good for you. Do that, okay? But for now, we're just going to say that angle or the side AC is larger than side DF. Now again, there's something you got to catch here. Guys, you can't just say, oh, look, a triangle 100 degrees. Look, a triangle 95. So this side here is bigger than this side here. No, you have to have two congruent sides and an included angle, two congruent sides and an included angle. And then you can use this theorem. Okay, now I'm going to pause a second and be quiet while you guys finish copying all this down, okay? Okay, now, listen, there's a very intriguing, that's a good word, intriguing proof of Theorem 5.10 at the bottom of page 248. Or is it 5.11? Yeah, 5.10. For those of you who like the why questions, you might want to check it out. In fact, I would encourage all of you to read it. It's really deep. It's really cool. Of course, all math is cool, but this is really cool. There are a lot of extra lines that you have to draw. It's a total of 13 steps. You're not going to be tested on it, so it's your decision. It's your call to make, but it's really, really good. A really good proof, and it really shows you how helpful proofs can be in proving some different things. So it's up to you, but you might want to look at that. Okay, continuing on. Here we go. Okay, Theorem 511. Go ahead and copy this down, please. You're responsible for it. I'm just going to be quiet. My voice is starting to go a little bit, so I'm just going to let you copy it down there, and then we'll talk about it. It's the converse of the other theorem, guys. Okay? So it's the exact same theorem, only instead of saying that we have, well, you'll see when you read it, but it's saying now that we have a larger side, thus we have larger angles, but you'll see that in a second. So go ahead and copy this down. If two sides of one triangle are congruent to two sides of another, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So it's the converse of the other theorem. The other theorem said if the angles were bigger than the side was bigger, this one says if the side is bigger than the angle is bigger. So just the converse. No big deal. Okay, I'll give you a couple more seconds. Copy this down. Please be neat, but please work quickly. Okay, please take some notes as you're copying this down. Please watch carefully here. Okay, so we're going to say that we have a side here, a side here, and a side here, and then we're going to draw the same sides again. I wonder if this thing is in three different parts. It's not. Okay, well, that's fine. We'll just trace it real quick here. So there's that side there. Pretty much the same, close enough. Now we're going to trace the side here. Trying to do a better job this time. It's a little better. And now we're going to swing these a little closer, actually. That, and then close the two. And there we go. And there we not go. All right. Try this again. That's great. All right. All right, let's go ahead and put, let's go ahead and call this CAT. We'll just call it cat, and we'll call this dog, okay? Triangle cat and triangle dog. Now here we go. Here's what it says. If two sides of one triangle are congruent to two sides of another, okay? Boom, boom, and those two marks there, okay? So if CA is congruent to DO and AT is congruent to OG. Okay, what else? And the third side is longer than the second side. I'm sorry, the third side of the first is longer than the third side of the second. So this side here, we'll call it a length of 8, and we'll call this a length of 6. So CT is greater than DG. Catch your if. Then what do we know? The included angle of the first is larger than the included angle of the second. It's not rocket science, guys. It's pretty simple. Angle A is greater than angle B. Now, guys, you just can't look at two triangles and say, oh, this side here is longer than this side here, so this angle here is bigger than this angle here. You have to have two congruent sides or two sides here congruent to two sides over here. Okay, and then if the third sides are one's longer than another, then you can make the conclusion that this angle here is bigger than this angle here. Okay, I'm going to pause for a second, finalize your notes, and then one more comment, and we're finished. Okay, very short video today. Very short video. Okay, here we go. All right, now I know this has been an amazingly short video, but I'm not being lazy at all. There's really nothing else to teach you except if I want to make you learn this 13-step proof. Okay, and I'm not going to do that to you. So, but most of the learning will take place during the homework problems. Okay, that's where you're going to have numerous chances to apply these two theorems to problems. Okay, so just make sure you work hard on the homework and make sure you really, really understand what you're doing, and that's where you'll apply these two theorems. Okay, all right, guys, that's it. If you have any questions, don't hesitate to call or email.